Welcome once again to ASOMNOFO online math class. In this video, we are going to discuss a very nice topic in mathematics, which is implicit differentiation. If you have been following my calculus work, you will find out that we have found the derivative of even the product, the quotient, and so many of them, and the basics of differentiation. So here we want to delve into the implicit differentiation. So those ones you have been doing are all explicit differentiation, in the sense that the variables x and y are written independently. For instance, we always differentiate functions like y equals 3x plus 5, for instance. A good look at this function will tell you that y and x are written explicitly. That is, they are staying alone on different sides of the equation. But a good look at these group of functions given to us will reveal to you that they are written implicitly, in the sense that they are mixed together. So whenever you are given functions like this, you must embrace implicit differentiation. It is yet the normal procedure you follow in your explicit differentiation, but the only difference here is that whenever you are differentiating y, which is not what you are differentiating with respect to, you must always attach dy dx. So whenever you differentiate y, which is not x, we are differentiating with respect to, always attach dy dx. So let us take these two programs to exemplify what we mean by implicit derivatives. Okay, then the first one we have x squared plus y squared equals 4. So let me differentiate x squared. As usual, the 2 will come to the back, which I have 2x 2 minus 1 plus, if I differentiate y squared, I'll have 2y 2 minus 1. But because I've differentiated y, which is not x we are differentiating with respect to, I will attach dy over dx equals, when I differentiate any constant, I will get 0. So this will give me 2x plus, because 2 minus 1 is 1, plus 2y, then dy over dx equal to 0. Let me move this term to the right hand side. I will have 2y dy over dx will give me negative 2x. This positive here crossing over is negative. So to get rid of these 2y, I will divide both sides by 2y so that I can get a value for dy dx. I'm dividing both sides by 2y. 2y cancel out. 2 will cancel 2 here. So finally, I'll have that dy over dx is equivalent to negative x all over y. So I'll have negative x over y. That is the solution. So dy dx is minus x over y. So let's take the second question. So the second question is x squared y plus y squared x plus 4x equal to 1. But looking at these two terms here, you will find out that they are all products. You will see that x squared is multiplying y and y squared is multiplying x. So you must employ the knowledge of product rule. So product rule will take place here. So to avoid complication, I will take the derivative one after the other. After, I will fix it in accordingly. So let me take the first term here and differentiate. When I have x squared y, I will say let v be the first term, which is x squared, and u be y, the second term. Remember that dy dx for product rule is v du dx plus u dv dx. This is the formula for product rule. V du dx plus u dv dx. Now we've got our v and u. The only things we need here are du dx and dv dx. So let us get du dx and dv dx. So dv dx, that is v with respect to x, dv over dx will give me 2 will come to the back, 2 minus 1. This will give me just 2x. Then du dx, du over dx. You see, I'm differentiating with respect to x, and this is y. If I differentiate y ordinarily, I will get just 1. Because I'm differentiating y, which is not x, I will still attach dy dx. But 1 dy dx is the same thing as dy dx, because when you multiply anything by 1, you still get the same thing. Then, joining together, dy dx for that particular term only will give me v is x squared, multiplying du dx. Du dx gave me dy dx, so I'll attach dy dx plus u, my u is y, dv dx. dv dx gave me 2x, so it is multiplying 2x. Okay, so at the end of the day, I'll have that dy dx is now equivalent to x squared dy dx plus y times 2x is 2xy. I'll keep it for this term. I'll get this term again. I have y squared x. I can say let v be y squared here and the u be x. I'm differentiating this independently again. After I'll fix it in the right place. So let me get dv dx. dv dx will give me 2y, 2 minus 1 of course. But if we remove 2 minus 1 is 1 and power of 1 is nothing. So I'll attach dy dx because this is y, not x. Okay? Then let me get du dx. du dx will give me, if I differentiate x, I'll just get 1. Then I will still plug in into this formula. I'll have that dy over dx equals v, my v is y squared, multiplying du dx. du dx is 1 plus u, my u is x, multiplying dv dx. dv dx gave me 2y dy over dx. Simplifying, I have that dy dx equals y squared times 1 is y squared plus x times 2y is 2xy dy over dx. Then having got this, I will now fix everything in the equation. Seeing x squared y, the derivative will give me x squared. I'll use this to replace my x squared y. I have x squared dy over dx plus 2xy. Seeing y squared x, I'll put plus y squared plus 2xy dy dx. If I differentiate 4x here, I'll get 4 plus 4 equal to, differentiating a constant, I'm getting a 0. I have to clean up here to continue. From here, I'll have, let me collect like terms, all the dy dx should be together. So I'll match these two together. So I have x squared dy dx plus 2xy dy dx. Then I have equals, let me move this one to the right hand side. 2xy crossing over will be minus 2xy. Y squared crossing over will be minus y squared. And plus 4 crossing over will be minus 4. So factoring out dy dx, which is common here, I have dy dx into x squared plus 2xy. This is what I'm having when I factor out dy dx, because I'll be left with x squared and 2xy here, equals, let me write the power first. So I have negative y squared, negative 2xy, negative 4. So to get rid of this x squared plus 2xy. I will divide both sides by that. X squared plus 2xy over x squared plus 2xy. This cancels out. Hence, dy over dx is equivalent to minus y squared minus 2xy minus 4 all over x squared plus 2xy. And this is just the solution to that function. Okay, so if you've enjoyed what you've watched, kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. Thank you for viewing.